jamais, jamais connu des lois.
Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Yeah, hi everyone. My name is Vishnu Vardhan Chikoti, and then in this session, I'm going to talk about my learnings from chaos experiments. About me, I have about 17 years of experience across site reliability engineering, which includes chaos engineering, product development, and business analysis. It's a diverse experience that I have. Currently, I'm a senior manager SRE at Fanatics, and prior to Fanatics, I have worked at Broadridge, Goldman Sachs, Bank of America, Tectoro Consulting, and DBS Bank. So most of this experience is into investment banking, product development, or in the SRE areas. Other than this talk, I have also done few other things. One is like I'm a co-author of a book, Hands-on Site Reliability Engineering, which has been published recently in July 2021. I have done a couple of tech talks. One is in Conf42 SRE 2021 about a new enterprise SRE adoption framework called Arctic. And I have also spoken about chaos engineering and how it relates to error budgets in Chaos Carnival 2022. I also have a blog, xfgeek.com. It has content across capital markets, technology, and some other things. If you want, you can check it out. And from a location perspective, I am almost all the time at Hyderabad, India, from like the last 20 years. Before I get into the main topic, let's do a quick recap on what chaos engineering is. So this is like the definition from Principles of Chaos. I'm not going to read the full thing, but if you see, there are like three main parts to it. So one is that it is about experimentation on a system, and then the second part is building confidence, and then the third part is about the turbulent conditions in production. Right? So now, when an experiment is done, it can result in a failure that the system is not able to withstand that condition, or it can result in a situation where the system has actually withstand that condition. So if it has actually able to handle that, then it builds confidence that okay, like this can be handled. And if it doesn't, then we need to go back and actually look at how do we fix it. The next thing is about the turbulent conditions themselves. So what turbulent conditions can actually occur in production? So the first one is the famous application or service unavailability. So we all know that there can be chaos monkey, which can be deployed and it can randomly shut down services or applications. And this is a famous thing. And coming to the modern way on how we develop, deploy applications and expose it to users. So there are like various components. So we might deploy it in a on-prem system. We might deploy it on cloud, multi-cloud, hybrid cloud, one region, multi-region. So there are like various different ways we actually deploy. We replicate across database instances, and then the users themselves are now like at a very high scale where they are trying to they are actually spread across the globe and accessing that over their Wi-Fi, broadband, or some wireless connectivity. Right? So in such a scenario, like there are like so many network hops between the users requesting for something and then getting back what they want. Right? So there can be delays in the network, there can be failures in the network like packet loss or packet corruption kind of a scenarios, or we can have a resource utilization problem with respect to CPU, memory, or IO related issues. Now, when we consider an application, let's say running on a VM, so it's not that particular process is running. So there can be other things that might be running, which can be an infrastructure agent for infrastructure automation. There can be an agent for observability purposes. There can be an agent from security purposes. So there can be various other agents, and they might actually cause a problem which can create that CPU situation. How much you test your application, like when you deploy it in production, and then when it is running in an ecosystem with other processes, then the other things can also cause a problem. And configuration errors, so we have all seen that, like when there is some configuration error, there can be a massive incident as well. So it's better we try that on a small blast radius by injecting that and then verifying how the system behaves. And then database failures. So with database, we can have logs, we can have transaction log fill-ups. So there can be contentions, so there can be other things in the database. So how is your overall system actually working or behaving in this particular scenario? So that's like a quick recap on what chaos is. Now, coming to actual learning, so what I've actually learned from my experience with chaos engineering since the last like 4-5 years. Now, one is about the tools themselves. So being a technical person, like we are all like very interested about what tool to use the moment we know that, okay, there's a chaos engineering that needs to be done. Now, when we look at a tool, so there are like various tools now available, open source or from a vendor. Now, some of the thinking that we need to look at is like whether we are going to use this particular tool just for a team or a department or at an entire organization level. Now, when as you like broader your scope, so what you observe is there is a variation in runtime. So how the applications are actually running. So are they running on VMs? Are they running on on-prem? Are they running on cloud? Or they running on Kubernetes kind of environment? So where they are actually running, and then how they are connecting with each other. So that would be one variation. And the next variation that you would see is like the architectures themselves, on like how again they are deployed, how you are trying to maintain the HA for that, how you are trying to replicate. So there can be some differences in that. And then the application maturity itself, like given some standard architecture patterns and design patterns, now how each application or service has implemented them can also vary. So like the overall maturity of like what they have actually considered and at what level they have implemented also differs. Now, if you run chaos experiments on a particular blast radius, and then you're saying that, okay, the same thing will also work for another set of applications and all, like that might not actually exactly match. So there will be differences on what has been implemented. And next is about the policies. Now you take an organization, so there will be like various things like what would your infrastructure team actually allow you to do on your applications, or in like, you know, when you keep expanding that particular scope of where you want to run the chaos experiment. And then there will be certain policies from a security perspective on what experiments you can run and in what way you have to run. Like though the tool has a capability that might not be straightforward to implement given that. And then there will be like change related policies now. And then there will be incident related policies, like how you are like making sure that what you are actually going to run is in line with these all policies. So that's one thing about the tools that I have learned. And then the second thing is about the actual tools themselves. There are, like as I said, many tools available. The first one is obviously very famous, Chaos Monkey. We all know that, and that's what it started. And then there is Simian Army. I didn't mention it here. And then there is Varian, which is basically has failures for based on protocol like HTTP, MySQL, and then error conditions can be like you are returning an error or you are injecting a delay. So those conditions. And then there is Spring Boot Chaos Monkey. Basically, you add certain configuration to a POM file and you build your Spring Boot application, and then it will randomly start injecting that faults. And then Chaos Blade is from Alibaba, which has various chaos experimentation scenarios, including like attacks on the JVM level or the fault injections at the JVM level. And then there is Pamba, which is basically for Docker containers. So it can run as a standalone binary, or you can inject some libraries into your container and then use Pamba as well. And there is Chaos Mesh for Kubernetes environments. Similarly, we have Litmus for Kubernetes and cloud native environments. And then there is Chaos Cube for Kubernetes environments. And then there is Seetulhu, and we have Monarch from T-Mobile, which is used for Pivotal Cloud Foundry based applications. So if you have deployments there, then Monarch can be used. And then there is Mangle from VMware. So there are various fault injection available for VMware related or at a VM level. So there are like various things which are available through Mangle. And then there is AT&T Resiliency Studio. And then there is Muxi, which is also a proxy like Varian. So you can create, put Muxi as a proxy, and then you can inject like response code failures or inject delays or any like network related failures also through Muxi. And then there is Chaos Toolkit with various integrations that are available. Now again, like which tool you want based on where your ecosystem is, where your application ecosystem is, and then what is your blast radius. So based on that, it can be used. And then there are also some operating system native features that can actually be used. So if you look at these tools, like how they are implemented internally, there are like some common things that are actually used. So some common Linux features or some common Windows features that are actually used. And then coming to the actual scenarios, like what I have seen while injecting chaos experiments. So one is like reconnect failures. So most of us who have worked for a long time can connect to this reconnect failure. Like let's say we have an application and running, and then suddenly it can't connect to the database. Like how is it actually behaving? So is it actually like not able to reconnect anymore, or is it hung, or like what kind of things are happening, right? So yeah, so that's one thing that I have seen. So we need to look at how to fix it. And then the timeout problems. Now if you inject a network delay, like how is your timeout being handled in your service or UI or whatever is that you are trying to like verify, right? So or like, and then is it actually let's say it's a UI, is it actually crashing the timeout and throwing a proper message, or is it just throwing a 504 error? So and then there can be crashes, like whether it again can be a service or a UI or a mobile app or whatever it is, like it can simply crash. So based on the injected failure condition, so is it something which is happening? That's something that needs to be checked. And then the master slave setups. Now let's say you bring down the master instance, and then you have like multiple slaves also available, and is the election actually working fine, and then is one of the slave actually upgrading to master? So that's something that can be checked. And now the other thing that can be done is like you disconnect the master from the slave through a network failure condition. Now is the slave actually thinking that the master no longer exists and it being upgrading itself to a master, and then we have a split brain scenario. So that is like other kind of scenarios that can happen. And it then again, depending on what actually happened, you will have a fix. Like you need to have like three nodes, like one master and two slaves, where even if one master disconnects from the slave through some network problem, the slave can connect to the other slave, and then it knows that okay, the master is still alive, right? So there can be like various fixes, various things to look at based on what the problem has been identified, right? And then the auto scaling thing. Now if you inject a high CPU condition, or you are trying to bring down few instances, is your auto scaling actually working properly, that the scaling is actually happening to bring back the required instances, or to bring up a new instance based on the CPU or memory injection that would have been done. And then the HA setup, again, like how is your high availability working when one of the instance is actually not available? Is it kicking in correctly and then working? Then exception handling. Let's say there is a user who is trying to do some transactions, and then there is a failure at a network or these whole timeout things. And then how is it actually being handled on the US side? Again, like let's say he has done a buy transaction, it has actually hit the server and the buy actually got processed, but the written was not properly handled in the UI. So then that will be a problem. The user will not know what exactly has happened. So are you actually like, let's say there is a timeout, or there is some other error coming from backend, are you actually taking the user back to some kind of a screen where he knows like what exactly has happened overall, and that kind of a user experience. And then observability. So this is not directly directly related to how the application has withstand the turbulent condition, but other things that can be considered are like observability. Like when these kind of errors are actually happening, are you actually logging it, or are you catching it within your observability data? And then observability is the data, and once you have the data, do you have the right monitors in place when this kind of things has happened? Actually, did the monitoring pick it up or not? Right? So in certain cases, yes, we have set up the observability, but we haven't set up the monitors. And once we have set up the monitors, the next thing is the alerting being done through the right channels? Are you messaging someone, or are you emailing someone, or are you actually paging someone? So this kind of alerting will also come into the picture, that you can actually verify whether that has actually worked fine or not, right? And then error budgets. Now when these errors are happening, 500s or whatever errors are actually being sent back, are these being recorded and adjusted against the error budget? So you don't like create a major impact to the error budget to chaos experiments, because it's a small blast radius, but still you can verify that whether they are reflecting there or not. And then auto recovery. If you have auto recovery setup, you can check whether the auto recovery has actually triggered correctly and then recovered the instance. For example, you are trying to bring down an instance, and then did it actually through the monitoring, did it trigger the auto recovery, and did it actually bring that instance back, right? So that's another thing. And then the other learning I have is about injecting multiple failures. So we don't actually inject multiple failures at the same time across the ecosystem. We inject like kind of one failure at a time. Like if you inject like too many failures like parallelly at the same time, you don't know like what went wrong and what would have actually caused it. That is the other thing. And then how do you actually handle the identified weaknesses, right? So when you have actually identified some problem through chaos experiments, it comes back to the product development backlog, and we have this problem of like it's basically it goes into the technical backlog, because this is some kind of a technical problem that you need to fix. Now how do you actually prioritize this and get it fixed? So it depends on the scale of the problem. Now you would have injected again the chaos experiment on a small blast radius. Now what happens if such a problem happens at a widespread thing? So basically, like what would be the impact and what level of problem it would creating? Like you need to prioritize it accordingly, and either utilize your 20% of tech backlog that can be allocated in a sprint, or if it is a bigger problem, like then you have to allocate more time than the 20% to fix this problem. And then knowledge sharing. So once you have done the chaos experiments and learned something from that, it is important that you actually go back and share within the organization that these are the experiments that were run, and this is what are the results that we saw. And if there are any observations like the system did not withstand that, then what did you actually do to fix it? And because in certain cases, the similar patterns or the architecture patterns will be used across the enterprise, and then it's important that you go back and fix the different places that the same problem might occur. So so that's my talk, and any questions you have, like send it on Discord, and thank you.